Hey, welcome to the shop. Today we're building a go-kart. Now this isn't designed to be the fastest or biggest engine go-kart on YouTube. There are other channels that do that. This was designed with a very specific purpose in mind, and that purpose is to have a go-kart you can build with your kids that's simple, even for a beginner, and affordable. I gave myself a few rules when it came to this build. First of all, I'm only going to use new parts at prices available to the general public. Second, nothing fancier than a chop saw and a welding machine. That means my machine tools, my tubing bender, and CNC are sitting the bench on this one. And last of all, it needs to reasonably be built by a beginner in the course of 3 weekends, which means we're going to be buying a lot of off-the-shelf parts to add to this cart. Now, go-kart build starts with a frame, and frames can get really complex, but when you boil it down, all you really need is a rectangle. In fact, this entire frame was built out of a single 20-foot length of 1-inch square tubing. The side rails are cut to 4 feet long, which is about right to fit riders from ages 7 to 12, which, fits right in with my kids. The front and rear of this rectangle are going to be the axles. First, let's build the front axle by attaching this spindle kit that I got here. I'm just using some weld coupons to be able to shim and prop everything up and add a little bit of caster angle to the front steering. Although at the speeds this cart will go, it probably doesn't really matter if they were just sitting vertically straight up and down. To build the rear axle, I just need to attach 2 5/8-inch bolts to either end of this tubing. Now, one of the bolts is longer by 1 inch, and that allows for the brake drum and sprocket you'll see us put on later. The extra tubing here is helpful to align everything and have it sit flat. Whenever you're welding on zinc plated or galvanized material like these bolts, it's important to use enough ventilation as well as a respirator to keep from breathing in those fumes because they can be pretty harmful. Now when I weld these together, the bolt head has a lot more mass to it than the tubing itself, so I've set my machine up higher to be able to penetrate into that bolt head, and I'll start my weld there and then move over towards that tubing, allowing it to bridge the gap. That way I can get a sound weld that's penetrated into the bolt without melting through my tubing. I'll put the whole thing together, making sure that the rails are parallel and using some switchable magnet squares to hold the axles in place and centered while I tack them on. Notice how I'm moving around while I weld this out, and I'm welding the fillet welds last. These two things are going to reduce distortion by quite a bit and help everything to stay square. If you want to learn how to weld and fabricate yourself to build cool projects like this, but have struggled to make the traction you were hoping for, I've packaged all the information you need in one place in my affordable online courses. There are courses for each of the common welding processes where I walk step by step through, telling you exactly what to do in practice exercises. You can find all this linked in the description below. I think it'll really help you out. The basic frame is done, and I'm going to test fit the wheels and spindles, and I'll show you how I put that drive wheel and brake together in a minute. Setting the seat and engine temporarily in place, this is starting to look like a real cart, and what we've done so far could easily be done on your first day of the build. Next, I need to install some cross members to mount the seat and the engine. Even though this is a small, simple cart frame, there's still a fair amount of welding to do. Well, now's when it gets really fun. So everything went together pretty well. I made one small design change by putting the seat rails front to back between 2 cross members. That way I can drill new mounting locations whenever I want to accommodate different size drivers. All right, let me show you how I put together the drive wheel. Now for wheels and tires on this, I use these wheel tire combinations from Harbor Freight. They aren't necessarily designed for a go-kart because this is going to have such low loads of small riders, and I'm designing it to run at really low speeds. They should be okay for this application, but if you were to run something with heavier riders or higher speeds, I'd recommend getting a dedicated wheel tire that's designed for a go-kart. In order to drive these wheels, I need to take apart the split rim, and I'm going to use the mounting bolts for that to attach a drum brake and sprocket. I'm using a mini bike drum brake and sprocket setup that I purchased, but none of the holes line up, so I need to mark this to drill matching holes in the drum, and then I'm going to check and just make sure my marks are centered, at least by eye. These wheels have quite a bit of run out on their own, so I'm not concerned about this being perfect, but I want it to be as close as I can get. Once I had some holes drilled in there, I used these steel spacers and some longer bolts to assemble it together. Okay, so transferring the torque through those spacers and longer bolts, that's not going to be ideal, but this is a relatively low torque situation and it's proven to be adequate as I've tested this out. To finish the chassis, I need several pieces cut out of some thick sheet, and instead of spending all day with an angle grinder, I ordered them from an online laser cutting service. I just drew them up in a free online CAD package, uploaded them to Send Cut Send. It's a service I've been using for years, and I get an instant quote, click buy, and they show up a few days later ready to go and install. The first thing out of here that I'll put in place is the engine mounting plate, which has some slots to allow me to adjust the tension of the chain. I'll actually mount the engine to the plate. That way I can make sure that the position side to side is in place and everything's lined up. Rather than welding these entire long seams, an intermittent weld should be strong enough to hold it in this case. Let's get to work on the steering. For the steering shaft, I'm using some 3/4 inch round tubing and attaching the pitman arm, which I had laser cut. To allow the steering shaft to rotate, I'm going to use some mounted bearings. Now here's a little trick you might not know. So typically when you buy round tubing, the outer diameter is actually a little bit over the nominal size, which is frustrating if you want to use it for a shaft. But what I did is I bought 20 millimeter round bearings, and 20 millimeters is just a little bit bigger than 3/4 inch of the shaft, which is going to leave a gap and cause it to run out a little bit. So it wouldn't be good for a rotating shaft, but for a steering shaft, it works great. I had these plates laser cut to mount the bearings, and the first will attach to the front frame rail. The geometry on the steering isn't perfect, but it works pretty good for what we're building. Now to mount the upper bearing, we need an upright support from the front of the cross member. I marked and cut a notch in the tubing, then mounted the bearing plate to the other side. I've just set it at a 45-degree angle coming forward out of the front cross member. I need to attach a flange that I had laser cut to mount the steering wheel. I just used a ruler to make sure everything was aligned properly. Now for the pedals. I had 4 of these tabs cut to mount the pedals and drilled the hole out to the exact size for the pedal shafts. They can be welded in place, and the pedals seem to work pretty good. For the cables, I had these tabs cut to weld to the frame rail. They have a slot to install the cable into. Now let's install the brake. It slides right over the axle, but I need something to keep it from rotating as it's trying to stop the drum from spinning. I was going to use a tab and a fastener welded in place, but instead I decided to just use a piece of tubing and weld the actual brake itself to that tubing. Keeps it simple, and I'm not going to remove this anyway. The wheel slides nicely over the brake, and I can mount the cable for testing. A shoulder screw and lock nut attaches the front end of the cables to the pedals. Let's prep the engine. I'm using a 79cc Predator engine from Harbor Freight. It's their smallest Predator, but it should have enough power for the size of rider and the low speeds that I'm expecting out of this cart, trying to keep it as safe as possible. It sounds pretty good, actually. The first thing I need to do is install a clutch onto here. Now this is a centrifugal clutch, which will allow the engine to spin freely when it's idling, but when it speeds up, it'll engage the outer drum on the clutch to be able to drive the wheels. This one has an 11-tooth sprocket for number 35 chain. That's the smallest sprocket that I can get. And I wanted the smallest front sprocket because I'm trying to keep the speed on this cart pretty low. Next, I'll rotate the pull start to be able to pull from the other direction, which will be the rear of the cart. It's going to put my label upside down, but it's going to be much easier to start. And while I'm at it over here, I need to add something to be able to engage the throttle. Now I could have made my own mount for the throttle cables, but I picked up this kit from Go Power Sports that will allow me to attach a throttle cable right to this engine. It's pretty cool. It has a bracket that screws right in place, as well as a return spring and the ferrule that you need to attach to your cable, allowing it to pull this lever here. Now that everything's in place, let's go ahead and fire it up. Well, it's looking like we're all systems go. I can go ahead and take it apart to finish this thing up. I'm just cutting a small floorboard out of this 18 gauge material. I'm using a plasma cutter here, but you could just as easily use an angle grinder to make this cut. To hold the floorboard in place, I'm using short intermittent welds. Notice how I started at the center of one end, worked my way out, then up the side. This is going to help it stay flat. I ground down any sharp edges, gave the royal blue rattle can treatment, and I can put it back together. After the first test, it was a little faster than I was comfortable with, so I actually changed the rear sprocket from a 60 tooth to a 72 tooth to slow it down just a little bit and slowed down the governor just a little more, giving me a top speed right around 15 miles per hour. My kids had a blast driving this thing around and testing it out, and seeing the smiles on their face, I couldn't help but taking it for a little spin. Does this not look so ridiculous? Man, driving that little cart makes me want to build one for myself. You know, maybe a vintage style cart, get out the tubing bender. Now, I have put a list of some of the parts that I bought, so you can find those if you want to build a cart yourself, as well as links to those files that I had cut out by Send Cut Send. Down in the description, you can see those as well as some other helpful videos if you want to learn how to weld. As always, I really appreciate it if you hit that like button if you enjoyed this or learned something here. And until next time, weld safe, and we'll see you then.